Hi, my name is Wei Te. I'm a senior AI ML specialist solutions architect. Today, I'd like to share with you a demo that we developed that uses generative AI models to achieve super resolution for any video content. Today, standard approaches for upscaling video content typically involve pretty complex processes like frame interpolation, denoising, filtering, post-processing, and so on. There are several approaches that are notable in achieving these effects, including using commercial off-the-shelves or using open source tools like FFmpeg. Both of these approaches have their disadvantages in terms of licensing costs and complexity in managing the infrastructure and so on. With the generative AI model, now it's really easy to create super resolution images at scale. These models are trained with millions of images to learn these common patterns so that it can produce a super resolution from the original images. So some of the notable generative AI techniques including generative adversarial network like GANs, vision transformers, stable diffusions, and so on. In this demo, we'll showcase an end-to-end example that uses a GAN model and vision transformer, and use AI services and AWS orchestrators to orchestrate the workflow, which takes in a low-resolution video and produce a super resolution version of the video at scale. So with that, I'll show you the demo. We have some samples that already has gone through this orchestration process to help simplify this demo. You can see that it contains video contents that span across different genres, such as animation, movies, and sports. So I'll show each one of those in action. First, I'll go with the animation. The video on the left hand side is the standard resolution, and the right hand side is the one that has gone through the video upscaling process. Another example would be a movie. And finally, sports. Next, I want to show you how we go about building these solutions end-to-end. This architecture diagram shows a user workflow that involve using the web interface that is hosted for the user, where they can upload a standard resolution video into an S3 bucket. Once the video resides in S3 location, there's an event that's triggered a Lambda function which invoke an SSM run command. This command would invoke the video upscaling process that is hosted in an AWS parallel cluster. Parallel cluster will manage the auto scaling aspect to scale up the compute instances required to perform extraction of the video frames, encoding, and so on, as well as the GPU instances required to host the AI model to perform the upscaling process. There's also an FSX Lustre file systems that's mounted in this cluster to allow share access to the file systems so that these processes could access the data very, very effectively in parallel. In addition to that, we also have CloudWatch metrics to capture the performance metrics at any given point within this upscaling process. So this concludes the architecture for building a solutions that you saw in the demo previously. Thanks for watching.